My name is Claudio Pinhanes, and this is the CHI paper titled Integrating Machine Learned Data with Symbolic Knowledge from Collaboration Practices of Curators to Improve Conversational Systems. Traditionally in computer science, the source code of a program is composed of two mutually exclusive parts, code and documentation. Computers ignore the documentation, but developers read and work with both documentation and code. This paper explores a scenario where a computer is able to read the documentation of the program and use it to improve its performance and support better the work of the developers. The context of this study is the development of chatbots by content curators using professional interfaces such as the one shown in the picture. The curators list examples of questions associated to each answer. The curators also document each group of examples by giving it a name, a piece of text called name ID. The examples constitute the code, and the name IDs are the documentation. Working with the curators, we found out that they often use taxonomic structures to create the name ID. By mining and combining all the name IDs, a computer can create graphs such as the one shown in the right, which we call an intent prototaxonomy. This paper shows that it's possible to mine those taxonomies from the name IDs of the chatbot and use them together with examples to improve the performance of the system. The paper is structured around three research questions. The first is about the nature of the curator's practice of using taxonomies. The second demonstrates that a computer can use the documentation to improve the performance of the chatbot. The third argues that a computer can use the data from the documentation to improve the development process. We now address the first research question. Is using intent prototaxonomies a common practice of curators of conversational systems? We performed a qualitative study with curators of a professional development platform, called here ChatWorks. This study provided evidence that using taxonomic structures in name IDs is a deliberate and well-defined practice, aimed to facilitate the collaboration among all people involved in the development of the chatbot. We also did a quantitative study with almost 7,000 chatbots. We present an algorithm which mines the taxonomies automatically in the paper. Then, using this algorithm, we show that using taxonomies is a very common practice, particularly in more developed chatbots. We then investigated whether those taxonomies can be used by a conversational system to improve its computational performance. The basic idea is to use a modified machine learning classification algorithm in which the taxonomic data is embedded in the output space of a neural network. We tested three different ways to use the taxonomic data mined from the documentation: as a group of concepts, marked by the letter T, as walks in the knowledge graph, marked by S, and as strings of concepts, like a written description, marked by C. Our first tests were using data from a large chatbot in Portuguese language, comparing those algorithms to a baseline provided by the standard use algorithm. We saw decreases in equal error rate with the algorithm use plus S, and in the false acceptance rate with use plus T and use plus C. We then tested with the code from 200 professional chatbots. The algorithm use plus C decreased the false acceptance rate more than 10% in 48% of them. Due to time constraints, we will not present in the video the study regarding the third research question. We believe the studies presented in this paper support positive answers for the first and second research questions. We could also answer positively part of the third question. This paper described a conversational system which mines taxonomies from documentation of chatbot programs and combines them with examples. We are able to improve the accuracy of the machine learning algorithms and support better some of the curator's tasks. We see this work as a demonstration of the feasibility of the idea of having computers able to read and use both the documentation and the code of a program. We plan to explore similar ideas in traditional programs and in data notebooks like Jupyter. On behalf of all the authors of this paper, I would like to thank you.